Hi everyone, in today's video we are going to find out the field due to an uniformly charged thin spherical cell. For this we will be considering three positions. The first one is for points outside the cell, the second one is for points on the cell, and the third one is for points inside the cell. So for points outside the cell, let us consider a Gaussian surface of radius small r. Now we know that integration of E ds is equal to q by epsilon 0. This implies that E integration of ds is equal to q by epsilon 0, which implies that E into 4 pi r square. Here ds is the area of the Gaussian surface, that is why we will be writing here 4 pi r square is equal to sigma into 4 pi capital R square, because our charge Q is enclosed in this cell, by epsilon naught. 4 pi gets cancelled from both the sides. This implies that E is equal to sigma by epsilon 0 R square by small r square. Now, it can also be written as, this implies that E is equal to sigma can be written as q by 4 pi r square, again epsilon naught r square by small r square gets cancelled. This implies that E is equal to 1 by 4 pi epsilon 0 q by r square. Now if you want to write it in vector form, we can write it as E vector is equal to 1 by 4 pi epsilon naught q by r square r cap, where r cap is a unit vector, and for q greater than 0 it is along the outward direction, and for q less than 0 it is along the inward direction. Now for points on the cell, we can substitute small r as capital R in the derivation, and for points as such we get E is equal to 1 by 4 pi epsilon naught q by capital R square r cap. Now for field inside the cell, we know that there is no charge enclosed inside the cell. Whatever charge resides on the surface of the cell. That is why q is equal to 0, and if q is 0, E is equal to 0. That's all. Thank you.